a system where we store data, or it can be an application where certain programs run. What is the commonality? The commonality is whether it is an application or whether it is data system that is dealing with data or system that is dealing with task or operations, there is something called current physical system. To give you an example, you can have a bank where you are storing the information about the account and the details of the transactions which happen in the account in different registers. This possibility is there. So in the business, initially to start with, I have one way to store data, and I can also have movement of the data in one manner. So the movement of data that we have seen, this is the movement of the data. But how the data is stored and how the data moves, there can be some current system. Without the current system, you cannot have the modification or change it to, storing it in databases like SQL. There has to be some current system. That is called as current physical system. So current physical system is talking about whatever is present as is. That is called current physical system. But current physical system, I have to collect all information. So most of the time, I do what is called as requirement gathering. This happens in data also. So I gather the requirement, and the people who are playing the role of gathering requirement are called data analyst or business analyst. That is a better name. Data analyst is slightly different. Business analyst. Now, a business analyst will collect the requirement from the client, and based on the requirement, first you will convert it into a logical system. Logical system means the data was physically present in books in the bank. I'm just giving an example. Now you want to convert it into some files in your computer to store the data. But before that, I have to represent the current system logically, and this is done by a modeler. And the process which converts the current physical system into current logical system, it is called current logical system, is called modeling. The process is called modeling. The role is called the modeler. So here we have the modeler that is coming into picture. Better to keep modeler here. Okay. So current logical system. So to give you another example, which is from the layman's point of view, when you are going to construct a new house, the house is constructed, but how do I experience a house? I cannot. But I have to simulate that this is how the house will look. So I have to give them the idea. So I make a small model in the computer, or it can be a physical model also, and the model represents the actual building. So here also this model will represent the actual system. And the modeling methodology that we use for OLTP, online transaction processing system, is entity relationship model. Diagram is the one which is representing the model, but it is mainly the entity relationship model. This is modeling. Then in the current logical system, so all of us will get to the model, and this ER model is the current logical system. What about the OLAP? In OLAP, we will have dimensional modeling. It is called a DM. And in OLTP, it is entity relationship model. Now, this logical system now is taken up to design. That means modifications have to be made. So using the entity relationship model, we start making changes. So we have designer who designs. So you have something called high level design and low level design. In high level design, you decide distribution of data. In the entire flow that we have seen in the previous trainings or the previous sessions, how do we distribute? Where do we keep the OLTP system? How often we move the data from OLTP system to OLAP system? So this is decided in high level design. And in low level design, we decide table. How do we design table? So this is called low level design. So how many tables should I have? Should I have one table? Should I have two tables? That is called as low level design. So design of table, that is an example. Now, after the design is done, this is all paperwork. You're going to convert this into, when you're doing all this, it is converted to proposed logical system. Why? Because it is still in the paper form. So what we have is table, and the table usually is normalized. Now, normalization is a process of deduplication. And normalized table means we are going to deduplicate the data in the table. And finally comes implementation. When you implement, that is where a developer pitches in. What is the work of a developer? Whatever is the proposed logical system in the form of table, which is there in the paper, we implement. So this implementation is done by the developer. So this is where what we do, we create tables. We relate tables. We have data types, or data type is selected. Then you have business rules implemented. Okay, now the business rules are not implemented out of your own. It is implemented whatever is available as part of the design, whatever the modeler has shown, those business rules will be implemented in your database also. We will see how all this can be done. So this is called proposed physical system. So this is the movement of our design. This is how we go from modeling, requirement gathering, to design, to development. So that we will now look at the first part, ER modeling. Again, as I said, in this course or in this session, I am planning to take mainly the first two sessions precisely, which will give you some information on what is modeling, what is design. Our main focus of this course is development. Okay. Now let's take an example of how design or modeling starts. We can have something that contains data, which is like basically your Reliance Fresh, etc. We'll have number of offices, number of branches, and each of them will contain some information. Branch will contain address, name, city, phone number. So employees will be there in Reliance Fresh kind of a business. So we'll have employee ID, phone number, etc. So whatever contains the data, whether it is logical or physical. See, if I look at a check is physical. It contains data. But if I look at account is logical. You can't see account. The information of account is there, but you can't see something like an account. But check you can see. So you can have physical entity or a logical entity which contains data. This is called as entity. This is the first step to model the information that is present in the business using entity relationship model. Then we have Reliance Fresh example. Then we have branches. Then you have employees. Then entity can either be single instance or multiple instance. So this point is to be noted. What do I mean by single instance entity? If I look at a company like Reliance Fresh, it is only one instance. Whereas if I look at branch, there can be multiple branches. The information contained in the branch is the same, but the detail, when the information is filled in for the branch, it is different. Like you have branch address will be different for different branches. Branch name will be different for different branches. City will be different for different branches. So this is how we have fill in the data. When you fill in the data, if you are coming up with multiple such instances, it is called multi-instance entity. Otherwise, it is called single instance entity. Entity can have attributes. So our purpose is every entity will have attribute means that information that it is containing. See, like address, like name, like city, phone number, size. These are all informations that are there. Now, when you fill in those information, these informations are called attributes. So we can have either a simple attribute or sometimes we can have compound attributes. That means attribute containing more piece of information, like address. You have the pin code, you have the city, you have the district. So you have a lot of information. Or sometimes it can be simple information, like only city. So attributes can be simple or compound. Then attributes can also be used to distinguish different entities. So you have key attributes and non-key attributes. So key attributes are attributes that describe the entity and differentiate one entity from another. For example, employee ID. I will know one employee ID is different from another employee ID. So this understanding is very much there. So this is called as key. Can we have many key attributes? Yes, we can have many key attributes. For example, to distinguish an employee, I can use the phone number. I can use the email address. I can use the Aadhaar card. I can use the passport number. So these different attributes which act as a key to distinguish or differentiate entities, instances, they are called as alternate keys. Alternate keys means, okay, there can be many attributes which can differentiate between two entity instances, but all of them are put under the category of alternate keys, out of which one we select as the most important distinguishing factor. And this distinguishing factor should be present for all the employees. Example, employee ID. Some employee may not have the passport. Some employee may not carry phone. It is very, and this is just a hypothetical situation. Nowadays, everybody has mobile phone number. Email address is also there. So there are certain things which are mandatory, certain things that are not. Mandatories can be used as primary key. Out of that, one of the mandatory thing, for example, would be passport number, can be the primary key. But in most of the system, we use our own primary key. We introduce, for example, ID. So we introduce our own primary key. And then we also have something called unique keys. So as I said, alternate keys, there are many attributes which can distinguish between two entity instances. They are called alternate keys. Amongst them, there is one important attribute which is called primary key, and then others are called unique key. Unique key means it is going to be unique. Then there is a way to recognize attributes from the requirement. How do we entity and attribute? So we say nouns are used to identify entities and also to identify attributes. Then the question will come, how do I know which noun to use as entity, which noun to use as attribute? If we are able to describe further, we use the noun as entity, like branch. We are able to describe further, like branch address, branch ID, etc. then that which cannot be described further is called as the attribute. Like if I say address, address also can be described further, but city cannot be described further. So if in your model, in your business, you don't need more information about that, like city is enough, then that becomes an attribute. But if city can be further described, then city itself can be an instance. This is the basis. So whenever there is a confusion, whether it is attribute or entity, we design it as entity. Okay. Now, attributes, we said, are simple attributes and compound attributes. So I have given some examples here. Color, if it is a retail store scenario, color becomes a simple attribute, like a shirt, green color, red color, orange color. It's a simple attribute. But whereas if I want to use a color for my image processing, then it becomes a complex attribute. Why? Because in image processing, it's not simply color, it is shade, it is hue, it is saturation. So that is called complex attribute. Similarly, address also. If I want a retail chain, address can be taken as simple attribute because it will be used for communication. Whereas if I am talking about a postal system, address can be a complex attribute. Then every entity can have relationship with another entity. So we have what is called as cardinality. And how do we recognize that there is a relationship between the entity? It is through a verb. For example, Reliance Fresh is there. There is one Reliance Fresh, and each Reliance Fresh has n branches, many branches. So therefore, the cardinality is one to many. This is called one to many cardinality. Example, branches have many employees. So there is one branch and each branch has many employees. So each employee can go to other branches also and operate. Possibility is there. If I am a if I am a division manager or a regional manager, I can go to different branches. Okay, so I become an employee irrespective of the branch. So this is also possible. So many to many is possible. Then, like one product can be brought by many customers. One customer can buy many products. That's another example of many to many relationship. Then you can also have one-to-one relationship, like owner of the branch. In Reliance Fresh, you have multiple branches where I'm selling. There will be an owner. So there will be one branch and there will be one owner. So one-to-one relationship. Then products are there. The products also can be part of batches. So many product can be part of one batch. This is many to one example. And one batch is going to be having many products, but one product will belong to only one batch. So many to one relationship is there. So this way you can relate the entities. Now, when you're relating to entities, there can be the relationship which is recognized using verb, and this relationship itself can have some attributes. Like suppose product, right, is sold to a customer by an employee in a branch. Like I go to Reliance Fresh, there will be some employee, and that employee will be helping the customer to buy a particular product in a particular branch. And therefore, the relationship is a relationship of selling, and that relationship can have attributes like date of sale, quantity, time, etc. So the relationship can have attributes. This is called relation attributes. Now, based on how many entities are present in the relationship can be binary or a relationship can be ternary. Relationship between two entities is called binary. A relationship between more than two entities is called ternary relationship. So binary relationship, ternary. Example, branches, owner. This is a binary relationship because there are two entities, branches and owner. Sales, if you see, look at sales, selling point of view. the relation is between product, branches, customer, and employee. So it will be a ternary. And usually what happens is a ternary relationship will be converted to binary relationship because it's very difficult to implement ternary relationship. Like for example, the relationship between customer, employee, branch, all this is there. So we have to create an entity. We will see how that can be done. Create an entity called sales. And then product will be related to sales, branch will be related to sales, then customer will be related to sales, employee will be related to sales. So now there you are converting ternary relationship into binary. Usually that is how it happens. So some exercise examples are there, which I will post on the next day. That is when we are actually starting, because this is also part of a demo session. And there you can try out the exercises on entity relationship model. Now, we said that a relationship between two entities, greater than two entities, we have seen. We can have more than two relationships between entity also. Like employees can be related to project as a project member, as a developer. Employee can be related to projects as project lead. So this possibility is there. So roles also come into picture. So this is how we can define the roles. Some example is also there, but we are not getting into detail. As I said, this part is only overview here. So we have to understand that I now have created entity and relationship. So this is your entity relationship. Now, after we have the entity relationship modeling, we then move on to what is called as how do we convert an entity relationship model into table. So conversion of entity relationship model to tables. I am not able to hear. It is Usharani who is talking. Okay, I think Usharani is. Yeah, okay. I think their mic. Usharani ji, you want to? Okay, fine, mute. So this is how it is. So next is conversion of ERM into tables, and next is normalization. After we finish everything, we will then look at how it has to be implemented. So this is where we are going to actually start the training. But before the training, I wanted to give a brief overview. So how do you convert entity relationship into tables? We will see in the next demo session, that is tomorrow. So these three topics we will see tomorrow. For today, I would just request Madhav, can you just share that link? So, hello, Madhav? Yes, there is a link, and that link we can use for logging in and subscribing. It is the subscriber link or the subscription link. So you all can subscribe and you all can use it for joining this training, and payment related things can be talked to. So subscription means student information form. Yes. So one moment. Yes. Any questions anybody has before I share the student information form? Yes, if there is no other information, so you can, we will be there for the next demo tomorrow. From day after tomorrow, the actual training starts. Just give me a minute while I get the link. Those who are interested can use the link.